Welcome back to AI.Code.Cast. We like to really dig into some of those problems that seem pretty simple at first glance.
Yeah,
But when you get down into it, there's all kinds of really fascinating complexity.
absolutely.
And today's no exception, right?
Yeah.
We're going to be looking at the string to integer conversion problem.
Yeah, the toy.
The atoy problem, right?
Hmm.
So at first glance, you might think, well, converting a string to a number,
Right.
that sounds pretty straightforward.
Yeah.
But there are, as we're going to see, there's some really interesting nuance and some potential pitfalls that we need to be aware of.
Yeah, and it can trip up even very experienced programmers.
Yeah, absolutely.
It's something that you might even encounter in a coding interview.
Absolutely. Yeah, it's a classic coding interview question.
Yeah.
And so, yeah, I'm very excited to have you here.
Thank you.
And to dive in, you're an expert in algorithms and data structures.
That's right.
So this is right up your alley.
Absolutely.
So let's
Let's get started.
get started. So first of all, let's just make sure everyone's on the same page
Yeah.
about what this problem actually is.
Right.
So imagine you're given a string
Mm-hmm.
like 42 or I think it's 123, something like that.
Yeah.
And the goal is to convert that string
Right.
into its numerical integer representation.
Exactly. It's numerical equivalent.
Right. So it sounds pretty simple.
Yeah.
But like I said, there's some catches.
Yeah.
We have to deal with things like leading right space, plus or minus signs.
Right.
And even like, what do we do if there's an invalid character thrown in there?
Yeah, those edge cases, how do we handle those?
Exactly.
And then what about those integer limits?
Yes.
We have to keep in mind that we're working with 32-bit signed integers.
Right. So there's only a certain range of numbers that we can actually represent.
Right.
And if the number's too big or too small, what happens?
Yeah, what happens then?
So those are all questions we're going to be exploring. So imagine we're in a coding interview
Okay.
and the interviewer throws this a toy problem at us.
Mm-hmm.
What's a good starting point?
Well, in that kind of situation, I always recommend starting with a brute force approach.
Okay.
It may not be the most elegant or efficient solution in the end,
Right.
but it's a really good way to just get your thoughts organized
Sure.
and to make sure you understand the basic logic of the problem.
Okay. That makes sense.
Yeah.
So let's break down this brute force method.
Okay.
Like, how would we actually implement this?
So picture this. You're reading the string, character by character, from left to right.
Mm-hmm.
The very first thing you want to do is just skip over any leading white space.
Okay. So like just those spaces at the beginning.
Right. Exactly.
We want to get to the actual meat of the number.
Exactly. We want to get to the good stuff.
Okay. What's next?
So next, you're going to be looking for an optional sign.
Okay.
So either a plus or a minus sign. That's going to tell you if your final integer is going to be positive or negative.
Okay. That makes sense.
Right.
All right. So we've handled the white space and the sign.
Yeah.
So now we're ready to actually deal with the digits.
That's right. Now we get to the heart of it.
Okay.
So you're going to start processing each digit one by one,
Mm.
and you're going to be converting them from their character representation, like how they're represented in the string,
Right.
to their actual numerical value.
Okay.
But this is where it starts to get a little bit tricky.
All right.
You need to build the integer incrementally as you go.
So we're not just adding the digits together?
Not directly, no.
Huh.
Think of it more like you're shifting digits to the left as you encounter a new one.
Right.
So let's say you see a 4.
Mm.
You multiply your current result by 10, and you add 4.
Okay.
If the next digit is 2, you multiply by 10 again and add 2.
Gotcha.
And now you have 42.
Oh, I see. So it's like we're building up the number
Yay.
piece by piece, kind of like using that place value system we learned back in elementary school.
Exactly. That's a great way to think about it.
Okay. All right. So what happens, though, if we hit a non-digit character?
Mm-hmm.
Do we just, give up?
No, not at all. That's where our error handling comes in.
Okay.
As soon as you hit a non-digit character, you stop processing the string.
Okay.
Whatever integer you've built up to that point,
Mm-hmm.
that's your final result.
Right. It's like we're saying, okay, we got this far. This is the best we could do.
Right, exactly.
All right. So this brute force method is taking shape.
Yeah, it's starting to come together.
We're handling white space. We're handling signs. We're even gracefully stopping when things get weird with non-digit characters.
Yeah.
Are we missing anything crucial here?
Well, there are definitely some potential pitfalls lurking in the shadows.
Okay, I was hoping you'd say that.
Yeah.
I have a feeling you're about to drop some serious knowledge on us.
Well, let's just say there are some things you got to watch out for.
Right.
If you want to avoid some nasty surprises.
All right, well, I'm ready.
Let's dive in. One of the biggest gotchas with this problem is integer overflow.
Yeah, those integer limits.
Right.
So how do we deal with that? Like, do we need to get out our calculators and start, like, figuring out the maximum value for a 32-bit integer?
Thankfully, no. We don't need to do any complex math by hand.
Okay.
The key is to be proactive, you know?
Okay.
So before you perform any operation that could potentially put your result
Right.
beyond those limits,
Mm.
you've got to check if it's safe to proceed.
So it's kind of like looking before you leap.
Yeah, exactly. A little bit of foresight goes a long way in coding.
Makes sense. Okay, so, like, give me an example.
Sure, so let's say you're about to multiply your current result by 10.
Okay.
Before you do that, you'd compare your current result to the maximum allowed 32-bit integer value
Right.
divided by 10. If your current result is already bigger than that, multiplying by 10 is going to cause an overflow.
Right, because then it'll be bigger than the max sum.
Exactly.
Okay, so it's like we're making sure we have enough room, in our integer to actually fit
Exactly.
the next digit.
Yep, you got it.
Okay, so let's say we do detect an overflow, though.
Mm-hmm.
Like, what's the best course of action there?
Well, that really depends on the specific requirements of your implementation.
Okay.
You might choose to return a specific error value,
Okay.
like, 0, -1, something to signal that things went wrong.
Right.
Or you might decide to clamp the result to the maximum or minimum.
You have to go to, like, cap it off.
Yeah, exactly.
So it doesn't overflow.
Prevent that from happening.
Okay, that makes sense.
Right.
All right, so we've got whitespace, signs, non-digit characters, overflows.
Mm-hmm.
Are there any other traps we need to be aware of?
Well, there's one more subtle detail that often trips people up,
Okay, I'm listening.
and that's leading zeros.
Oh, yeah. Yeah, those sneaky zeros at the beginning.
Yeah, like in a string, like 0, 0, 1, 2, 3.
Right. So do those actually affect the numerical value?
Well, it depends.
Okay.
Sometimes they might, sometimes they might not.
Okay.
It really depends on the specific application or context you're working with.
Gotcha.
In some cases, those leading zeros might actually hold some significance, and they
Yeah.
need to be preserved.
Okay.
But in a lot of cases, we just care about the actual numerical value,
Right.
so we can just discard them during the conversion.
So it's kind of like a style choice almost.
Yeah, you could say that.
Like whether we want to keep those zeros or just go for a more minimalist look.
It all boils down to what you're trying to achieve.
Okay, so this brute force approach,
Yeah.
it's getting pretty comprehensive,
It's a
right?
good solid foundation.
Yeah, we're handling white space, signs, non-digit characters, overflows, these leading zeros.
We've got all our bases covered.
But I have to ask, is there a more elegant way to do this?
Well, now that you mention it, there is.
Okay. I was hoping you'd say that.
There's a pretty powerful tool we can use to make our solution much more concise.
All right, I'm intrigued.
Are you familiar with regular expressions?
I've heard of them, yeah.
Okay.
They've always seemed a little mysterious to me, though.
Yeah, I understand. They can seem a bit intimidating at first.
Like some secret coding language.
Yeah.
But I know that they're very powerful.
They are, yeah. Once you grasp the basics, they become incredibly valuable for all sorts of text processing tasks.
Okay, so how can they help us with this toy problem?
Well, imagine instead of manually checking for white space, signs, and digits one by one,
Yeah.
we could just define a pattern that captures all of that in one go.
Okay.
That's what regular expressions let us do.
So it's like we're creating a blueprint
Yeah.
for the kind of string we're looking for.
Exactly.
Gotcha, okay.
So we can essentially say, hey, look for an optional sign followed by one or more digits and ignore any leading white space.
Okay, that already sounds way more elegant than all that brute force stuff we were doing.
It's a much more concise way to express the same logic.
Yeah, okay. Can you give me an example of what this regular expression would look like?
Absolutely. Let's say we have a string like meta42. A regular expression to capture that integer could be let plus l.
Okay, that's a lot of symbols.
Yeah, it can look a little cryptic at first glance, but don't worry, we'll break it down.
Okay, I'm ready.
All right, so let's start at the beginning.
Okay.
That little hat symbol, that means we want to match the very start of the string.
Okay.
So no sneaking in extra characters before our pattern.
Gotcha, we're starting right at the beginning.
Exactly.
Okay, what's next?
Next, we've got hull. That part means we want to match 0 or more white space characters.
Okay, so that's how we're handling those leading spaces.
Yeah, that's right.
Okay, so what about the actual, like, sign and the digits?
That's where capturing groups come in.
Okay.
So the part in the parentheses,
Mhm.
plus A plus, That's a capturing group.
Okay.
And it basically says, hey, this is the part of the string that we really care about.
A capturing group.
Yeah, it's like putting a spotlight on the important part.
Okay.
So inside that group, we have hap plus a. That means match an optional plus or minus sign.
Okay, so we're covering both positive and negative numbers then.
Exactly.
Right.
And then day plus means we want to match one or more digits.
So that whole thing basically captures the entire number.
Yep, the sign, the digits, the whole shebang.
Wow, so that one line of code pretty much does all the work that we were doing in that whole brute force approach.
That's the power of regular expressions. They can pack a lot of logic into a very concise format.
It's impressive. It really is.
And once we've defined our pattern, we can use a regular expression engine to actually search for a match in our string.
Okay, so if the engine finds a match,
Then we know we've got a valid integer.
and if it doesn't find a match,
Then we know something's not quite right with the input.
and we can handle that accordingly.
Exactly. We can either return an error or set a default value.
Okay, so it's giving us that validation step as well.
Exactly. It's a really powerful way to make sure we're only processing strings that fit our expected format.
So regular expressions not only make the code more concise, but also potentially more efficient.
Yeah, because these engines are usually highly optimized under the hood.
It's like we're leveraging all this powerful machinery to do the heavy lifting for us.
Exactly. And that can make a big difference, especially if you're dealing with a lot of data.
Right. That makes sense. But
Yeah.
I'm curious, even with regular expressions,
Mm-hmm.
do we still need to worry about those integer overflows that we talked about before?
That's a great question.
It seems like we're still ultimately converting a string to a number, right?
Right. So we still need to be mindful of those limits.
Okay.
Regular expressions help us extract the numerical part efficiently,
Mm-hmm.
but we still got to handle the conversion process carefully.
So it's like a two-step process. First, we use the regular expression to kind of isolate the part that we're interested in.
Yeah, like finding the needle in the haystack.
Right. And then we have to actually convert that,
Exactly.
being careful about those 32-bit limits.
It's all about combining the right tools for the job.
This has been a really cool journey.
It has.
Like, we started with this seemingly simple problem, right?
Yeah, deceptive simplicity.
And we explored this brute force approach. Then we got into these elegant regular expressions.
Powerful stuff.
I feel like my coding brain has gotten a serious workout today.
That's what we like to hear.
So now that we've looked at both of these approaches,
Mm-hmm.
what do you see as the main advantages and disadvantages of each one?
Well, brute force is definitely easier to understand.
Yeah, it's very straightforward.
You're basically just walking through the string step by step.
Yeah, it's very transparent.
It can be a good choice if you're working with a team
Right.
where not everyone might be familiar with regular expressions.
It's a good starting point.
Yeah, definitely.
But the regular expression approach
Mm.
offers that conciseness and efficiency.
Yeah, it can really streamline your code.
It's almost like it forces you to think about the problem at a higher level.
Thinking in patterns,
Right, exactly.
which can be really helpful for more complex problems.
But it does have that steeper learning curve.
It does. Yeah, those regular expressions can look pretty intimidating.
It's like learning a whole new language almost.
It takes practice, but it's definitely worth the effort in the long run.
Yeah, I think after today's deep dive,
Mm-hmm.
I'm convinced they are a valuable tool to have.
They really are.
So I can't let you go without asking,
Yeah.
have you ever run into any memorable toy disasters in your own coding?
Oh, I have.
I'm sure.
Early in my career, I was working on this system that processed user input.
Okay.
And, well, I totally overlooked the possibility of integer overflow.
Oh, I have a feeling this isn't going to end well.
It did not. One day, a user entered this ridiculously large number, and the whole system just crashed.
Ooh.
Yeah, it took me hours to track down the issue.
Yuck.
I definitely learned my lesson that day.
Yeah, those are the kind of lessons you don't forget.
Exactly.
It's a good reminder for everyone listening, right?
Absolutely.
To really think about those edge cases.
And to anticipate those potential overflows.
And that regular expressions can really be your friend.
A powerful ally.
All right, well, I think our deep dive today has given everyone a lot to think about.
I hope so.
We've explored this problem really thoroughly, right?
From multiple angles.
From all these different angles. Uncovered these pitfalls.
Yeah, and shared some hard-won wisdom.
And, most importantly, hopefully, we've inspired some people out there
To keep learning.
to keep coding, keep learning, keep exploring these fascinating problems.
That's what it's all about.
So to all our listeners out there, thanks for joining us on this coding adventure.
Keep those algorithms sharp.
And we'll catch you next time on AI.Code.Cast.